Advanced User Interface Solution. Concerning the HMI, the Advanced User Interface Solution, there are different technologies that permit to control the display information. Our MCU product, like Array family, support this kind of interface, from the touch to the graphics. For the graphics, thanks to our ecosystem, Array ecosystem, our external partner, we have some solution to help you to design this kind of interface. And Qt, it's a good example. Qt is part of our ecosystem and provides solution for Array family. For the voice, we have also another partner to provide you a solution. The voice is a standalone concept, so support 34 languages. It's a local languages recognition solutions, local algorithm without external command. Concerning touchless and touch, here it's based on our Renesas solution, Renesas IP. We support the touchless, the gesture recognitions, and we have traditional touch also. In my presentation today, I would like to focus on the touch and touchless solution. Graphics, Qt for RS MCU. As explaining, Qt is available for our Array MCU product line. A complete graphic framework and toolkit is available. The key feature, it's a hardware capability. Thanks to our hardware capability and to their solutions to provide the best-in-class graphic performance. Very small RAM footprint of the graphic engine. The support of the dynamic and scalable font with RAM footprint as low as 20 KB. The application, it's a HMI for target control panel in industrial building automation, for metering device, for white good applications. Qt for MCU is a complete graphic framework and toolkit with everything you need to design and deploy while on Array device family. Create your smartphone-like interface on Array microcontroller. It's really simple. Everything is ready and available. On our website, you can find also a link to access application note, training material, video, and there is a simple lab to explain you how to create smartphone-like user interface on our R6 family device. The capacitive touch trends. The use of the capacitive touch is accelerating. Before, it was reserved for high-end application. Now, it's become more common. End users request this kind of interface to control their HMI. For lighting control, for door open, for washing machine interface, oven, all these appliances have now this kind of interface. Capacitive touch consists of a design of touch key, buttons, slider, or wheels in order to control HMI. The merits of the capacitive touch. If we compare to the traditional button challenge, traditional physical buttons, the cost of this kind of solution, this physical button, could be very high because we have many parts to implement. We can have some failure to this hardware part. we need to put in place some measure against a water droplet, for example. And it's not easy at all to clean. Surface is not flat, several mechanical buttons, for example. And it's really true for all home appliances in your kitchens. All these kind of drawbacks are solved by our capacitive touch solution. First, the cost. We can realize low-cost interface to control your HMI just by designing electrodes. Touch interface, touch design, it's just electrode design, PCB pattern, nothing else. There is no problem with the buttons due to the fatigue, so we improve the durability. Concerning water, no need to put in place some measure against the water. The electrodes are inside your appliance. And surface is flat. It's really easy to clean. Have a look at your induction hub in your kitchen with touch interface for sure. And you can imagine you can really improve the design to realize futuristic design by combining your touch interface with LED, for example. Capacitive touch history. Renesas has a strong knowledge on the capacitive touch technology. We have integrated our first solution in a R8C in 29. It was based on home run measurements method. At this time, we supported only touch button application. The second generation was developed in 2013, and this one was a Renesas IP. We have developed this IP based on our knowledge, and this IP is integrated in the RX product line, and that offers high noise immunity to our customer. We support also mutual capacitance design. In 2018, we have released a new tools, the Qt tools, that permit to configure, to tune and monitor the capacitive touch solutions. We have an auto-tuning mode that permits to define the parameter for the driver and middleware. In 2020, we have released a new IP with new improvements concerning the noise immunity and sensitivity, and also new functionality like parallel scan. This IP is integrated in our RA family. In 2019, we have also passed UL and VDE certification needed for HA home appliance application. Since 2009, our solution was used by several customers thanks to our advanced technology and software. How our IP is working. Here it's a simple view to explain you the concept of our IP. The Renesas Touch IP is based on current to frequency conversion to measure change in capacitance. Here it's a very simplified model but will show you the fundamental of the operations. Quickly, here is the circuit operations and how the capacitance is measured into a touch result. First, a set of pulses are outcome in order to manage the charge and discharge of the connected sensor via the switch 1 and switch 2. The series of the pulse is referred to as the sensor drive pulse and operate at the frequency to ensure full charge and discharge of the sensor by the power supply. Next, as this switch cycle, the result in a draw of the current for the power supply. At the same time, the amount of the current supplied to perform this charging of the sensor is mirroring as an input of a current control oscillator. The pulse outcome of this oscillator is counted during a fixed time, which produces a numerical result defined as counter, as you can see in these graphics. Finally, when a touch occurs, this requires more current to charge the sensor due to the added capacitance of the finger. This increase of the current is mirroring to the current oscillator control oscillator, and it will cause a frequency increase. This frequency change causes the number of the pulse measured over the same fixed period of time to increase. And it is how a change in capacitance is measured in our IP. Our hardware IP is based on this concept, and this hardware IP is embedded in our MCU device to support capacitive touch technology. Our solution is perfect to design traditional touch like buttons, wheels, slider. As I have mentioned, last year we have developed a new generation concerning the capacitive touch IP, and this new generation is embedded in our array family. Is offering more, so we upgrade the hardware noise immunity by supported shield support and added also multiple frequency scan. We improve the sensor accuracy by added some register access to improve the signal noise ratio or the resolutions. We have also hardware structure in order to manage temperature drift. And on this latest generation, we support fast scanning and slow sampling. We are able to detect multiple fingers at the same time, thanks to our hardware. Multiple detections. We improve also the fast scan due to some hardware change. Now we will see that we can also use our technology for touchless or material detection application. Our capacitive touch solution overview. Our solutions permits to realize touch key and touchless function quickly. We are supporting self and mutual capacitance to realize touch function in many scenarios. We support the proximity up to 20 cm. Here it depends on the electrode side. We offer to our customer high noise immunity. We have posed some noise tests in order to prove it. Concerning our feature, what are our features? First, optimized system. the cost of the system. We can replace main MCU plus touch ASSP by only one Renesas MCU in order to provide the touch interface. In many systems, we can see this kind of architecture. We have a main MCU, for example, to drive HMI, to design the HMI interface. And we have a dedicated touch IP IC in order to manage only the capacitive touch interface. With our solution, RS6 and 3, for example, we can do both. We have a rich MCU product line. Array. All our array device has touch interface. RL78, J23, and RX device has also touch interface. Easy to develop. We have a deliverable in order to help you to design and to understand our capacitive touch solution. Application note, software, design guides are available. Concerning the software, we have developed QE tools in order to help you to configure, to tune, and to monitor the capacitive touch signal. This tool is embedded in our Square Studio and is going also to provide you the BSP through the FSP. Evaluation kit is also available in order to evaluate our touch capability based on MCU board plus electrode board. And for sure, device sample is available. Here is an example of our array device that embed the latest technology concerning our capacitive touch IP. Concerning this device, based on the CORTEX M23 core, 32-bit, we are using a 110 nanometer process dedicated to the low power. Temperature range -30 up to 105 degrees. We support large operating voltage from 1.6 to 5.5 volt. We embed high-speed oscillator to reduce the cost of the external component. Concerning the flash, up to 266 kilobytes of flash. We keep our data flash up to 8 kilobytes of data flash. Concerning the communication IP, we can offer in this device CAN interface. We embed advanced analog option, 12-bit ADC, 12-bit DAC. We have safety function for motor control application, for example. We have security function also embedded in this device. And concerning HMI, as I have mentioned, we embed our latest capacitive touch IP. Maybe more useful for you, here is the number of sales channels available for each device depending on the flash size and package for the Array2 series. Array2 series is part of Array family dedicated to the low power application. The Array2 E1 and L1 embed our latest technology concerning the capacitive touch based on the CORTEX M23. Concerning package, the smallest one is a 25-pin WLPGA package less than 3 by 3 mm that offer 10 sales channels. For the largest one, 100 pin in LQFP package, we can offer 32 channel. After, it will depend on the number of channels that you need to design your touch interface, slider, wheels, or key button. How to evaluate our solution, our capacitive touch solution? Concerning the array family, we have developed a board dedicated to the touch. Name of this board is RSSK, Renesas Solution Starter Kit. This kit is based on two boards, the main board, the CPU board, that embeds the RA2L1 100-pin LQFP package, based on CORTEX M23 38 MHz. And we have electrode board. This time it's a self-electrode board designed for slider, wheels, and 3 touch key. This kit is available on our website. Please find the part number if you would like to buy it. As mentioning concerning the capacitive touch, we have done some improvement on our latest IP in order to improve the sensibility, the scan time, and to get better results concerning the noise immunity. Here there is some comparisons between our previous generation and the new one. What we have really improved, for example, is the scan time, in order to get a better reactivity. We have also implemented some hardware feature in order to perform some parallel scan that permit, for example, to detect multiple fingers at the same time. Here, same, we improve the scan time. Concerning drift temperature, here it's for the noise immunity. We have hardware process to manage this drift temperature. Now, with our new IP, we support also chilled electrode, active chilled electrode, in order to reduce parasitic capacitance and also to get better noise immunity. We have also access now to some register, internal register, in order to adjust the sensibility and the resolutions. Result is that we are going to have a better signal-noise ratio and also a better accuracy or gains depending on the result that we want. All this new feature will help us to design interface for proximity or gesture recognition. Quick and effective tools, QE. It's the name of the tool that we have developed to help you to develop your touch interface. These tools will permit to configure all parameters of our driver and middleware by an auto-tuning mode. It will generate the appropriate code concerning your interface. For sure, later you can access manually or adapt some parameters through some GUI interface. This tool is integrated in our eSquare Studio in order to define all parameters. As you can see, the concept is easy to develop even for a beginner. You just need to configure the number of electrodes that you want to use and the type of the electrode, wheels, slider, and key button. After that, the tool is going to auto-tune to define the parameter by itself. It will generate the appropriate code using by our driver, and after uploading the code in our device, you will be able to monitor all the signal and to understand the functionality of each electrode, threshold, noise, touch counter, and all other effects. Renesas touchless solution. What are the main features? Proximity sensing, high noise immunity, and design flexibility. In order to prove this feature, we have developed several reference designs. For the first one, the proximity sensing, we have developing 3D gesture, 2D gesture reference design. For the high noise immunity, we have developed some reference design demo to prove our noise immunity against the water or with the use of a glove. Concerning the design flexibility, here it's some example where we are using different overlay in order to prove the design flexibility concerning the overlay. The video of this reference design demo are available on our website. If you need more information about Gerber, touch interface, how we have designed, how we have parameter our software, don't hesitate to ask us. During this complex period and all COVID-19 effect, we need non-contact HMI in order to avoid contamination. And it is why we think that our solution, proximity, gesture recognition, could help to answer the need of this market. Our technology is able to support the touch and touchless interface. Concerning the touchless, we can consider two types. Proximity. Similar function than the traditional touch, but at distance. We want only to detect a finger presence. Gesture control, where we would like to recognize the movement, the gesture of the hand in order to control the appliance. We have developed different proof of concept as reference design for the touchless button and the gesture recognition. Concerning the touch button demo, it's based on self-capacitance method. We embed RH2L1 or RX130. A video is available on our website. The 3G gesture demo is based on mutual capacitance design. And here, it's really to detect the gesture of the hand. The 2D demo is based on the self-capacitance design. All these demos are available as a reference design, and all documentation are available on our website. Gesture control reference design. Concerning the gesture control, we have developed different models and size to support the 2D and 3D technology and customer request. Compared to other solutions available on the market, done with video, higher sensor, or other, our solution is done only with simple electrode design and not affected by light. The solution is available as reference design. All information are on our website. We are going to look at two videos. First one is going to explain the 2D concept, and the second one is about the 2D. As you can see, we are able to detect up to 20 cm depending on the electrode size, and the accuracy is about 1 mm. We have passed some tests in order to prove our noise immunity, and our solution can be used in many applications.
This is a 3D gesture demonstration showing the operation of home appliances through the detection of hand movements using electrostatic capacitance sensing technology from Renesas. The electrostatic capacitance sensor integrated into the Renesas 32-bit MCU RX series enables highly sensitive detection of movement with high noise immunity. With the recognition of hand movements in free air, using electrostatic capacitance measurement, this solution allows the operation of home appliances using gestures, removing the need for touching a control panel. Unlike infrared and sound wave technologies, detection is still possible even if objects are introduced between the hand and the sensor. This allows the technology to be used when embedded in walls and other objects. The technology uses 5 proximity sensor electrodes which convert the position of the hand into X, Y, and Z coordinates within a 3-dimensional space. Any hand movement is detected as a change in these coordinates, allowing the technology to recognize a gesture motion as front, back, left, right, and up, down. The detection range of the technology is within 20 centimeters far from the front of the demonstration device. Within this range, the maximum positional accuracy of 1 millimeter is achievable. The coordinates of the hand position and the proximity sensor electrode sensitivity can be represented in real time using a monitor tool which operates on a personal computer. By combining this with a tablet computer, the user can confirm the gesture operation and its effect on the actual home appliance. Used in many different home appliances, such as controlling the door of a refrigerator or operating light switches without touching them.
Turn on the light.
Renesas has a full lineup of capacitive touch MCU products for different applications. 3D gestures are supported by all touch MCUs. Renesas Touch Solution adds value to your products with flexibility of overlay material, flexibility of product cabinet design, and easy development.
Touchless button. As explained, we have also developed a reference design concerning the touchless button technology based on self-capacitance. We are able to detect the presence of a finger at 1.5 cm without cross effect. The overlay is transparent and could be easily adapted for any kind of applications. Typical application, what's good? Toilet, for example, to control the toilet. Induction hub, elevator. We can adapt the design by added LED. And the concept is that this interface is controlled by our main CPU board. All of our information are available on our website. Based on the proximity detection, we have also developed a solution to control sensor application. In this example, we have embedded Renesas sensor to measure the air quality, temperature, and humidity. The MCU is a RA2E1 device based on CORTEX M23 at 38 MHz. Concerning this demo, the sensors are connected by I2C. All material is available on our website, hardware, software in open source and evaluation tools. Target application, ranger, air purifier, toilet, air conditioner. Concerning the electrode design, as you can see, the electrodes are about 20 centimeters square, and we have 5 electrodes to control the design. We can also see the active chip design. The data for this reference design are available on our website. Software, hardware, tools, everything is already available. Please have a look at the link to get all the data. A video is going to explain you the concept of this touchless sensor demo. The sensor board is connected to the PC, and as you can see, we are able to detect on each button the presence of the finger at 1.5 cm. We have all data concerning temperature, humidity, and we can select different modes, auto-tuning, power, or other mode. Here it's a really simple interface. For sure with Qt you can have a better one in order to provide the data to the user. Flexible overlay material. Now, just a quick look what can be done with our capacitive touch solution in terms of overlay. Concerning overlay, we can use different types of materials: wood, stone, cloth, tile, paper. There is no real limitation except maybe some air gap or the thickness of the materials. We have performed several tests and we have several demos based on different materials concerning this kind of application. We have also developed extended application based on our capacitive touch solution. On the left side, we have an example of a BLE electronic lock demo. There is a simple application on the mobile phones and the communication between the door and mobile phone in order to get the key code to unlock the door. Here we have two examples. One is with wood, another one is with mirror. Demo video is available on our website. In the center, it's a capacitive touch plus BLE in order to control light. Same, based on slider and button. And in this case, video is also available on our website. The last one, it's a capacitive touch plus motor control. With one chip, only one, we are able to control motor control, brushless, voice playback, and to control also the LED control or other motor control. Touch function is wheel, slider, or button. Thanks for following this session concerning our touchless solution to control HMI design. If you need more information or if you have questions about our solution, don't hesitate to ask our local sales, our Renesas local sales, in order to get more information. Any question is now welcome.